Hi everyone! In this video, I will present the work of the following. The title of the paper is From Traditional Data Warehouse to Real-Time Data Warehouse. It is a conference paper published in February 2017 in Advances in Intelligent Systems and Computing. The first two authors are Faculty of Sciences, and the other author is from the Institute of Computer Science and Multimedia of Sfax University in Tunisia. With the new business requirements for up-to-second updated information, and because timely data ensure better informed decisions, real-time data warehousing is one of the savior trends that provide an access to accurate, integrated, and consolidated view of the organization's information in real time. In this paper, the authors are interested in giving a survey on data warehousing starting from a traditional data warehouse to a real-time data warehouse. First, the survey focuses on data warehouse architecture. Second, it details the changes in the extract, transform, load process to deal with real-time data warehousing. Third, it sketches the integration data in the real-time data warehouse. And finally, a comparative study concerning the real data warehouse approaches is also presented in this paper. A data warehouse is an integrated and historized collection of data generally used to make strategic decisions by means of online analytical processing techniques. It integrates data that come from independent, heterogeneous operational data sources and create a single view about the organization. Once in the data warehouse, these data are turned into structured information that can easily be handled by decision-making processes. There are two arguments that justify the use of real-time data warehouse. First, the traditional data warehouse provides the state of the company at a specific time in the past, such as every day, every week, or every month. However, some applications require smaller temporal resolution, like for every hour. The real-time data warehouse enables the organization to find variants of its state even within a day. The second argument focuses on the fact that when a large volume of data is entered in the transaction systems in a single day, processing of extract, transformation, and load sometimes causes problems. The operation of the real-time data warehouse suggests frequent and regular additions in a single day. The table presents a detailed comparison of the traditional data warehouse and the real-time data warehouse environment. Next, we'll talk about some approaches to move closer to a real-time data warehouse and other approaches which represent a real-time data warehouse architecture and discuss the integration of real-time data. The criteria required for continuous updates without involving a shutdown are generally inconsistent with traditional ETL tools. To address this problem, new solutions that specialize in ETL real-time and data loading are needed. There are also solutions modifying conventional ETL systems in order to load a warehouse on a frequency approximating to real-time. A lot of work has been done on the real-time data warehouse architecture. These are the examples of proposed architectures. This architecture deals with the continuous loading as opposed to the periodic basis in traditional approaches. It is composed of three main parts: the data source, data processing area, and data warehouse. The source flow regulator is responsible for the identification of relevant changes and propagates them toward the data warehouse. Then, the data processing flow regulator is responsible for deciding which source is ready to transmit data. Lastly, the warehouse flow regulator orchestrates the propagation of data from the data processing area to the warehouse. The second proposed architecture assures the access to acquired data from different data sources in near real time. The components are Web Service Client, Web Service Provider, Metadata, ETL, Real-Time Partition, Data Warehouse, and Real-Time Data Integration. The component Real-Time Data Integration is used to integrate data from Real-Time Partition and Data Warehouse. If a user query only wants historical data, then this component sends the query to the data warehouse. If a query wants both historical and instant data, then this component rewrites the query to get and integrate data. To make data integration near real-time, different approaches have treated the integration of data in real-time data warehouse. In the first approach, the authors handle the problems of data integrity issues towards the need for accessing the real-time data warehouse by introducing a model that preserves the data integrity and availability. The model is based on a temporary duplication of fact tables that are concerned by the change of data while keeping their integrity constraints. In the second approach, the authors propose the real-time data warehouse architecture from a basic data warehouse architecture. This approach enables updates to the continuous data while keeping the most recent information in the data warehouse. This also enables any desired degree of freshness to queries. The architecture is made of three main components. These are Dynamic Data Warehouse, Static Data Warehouse, and Fusion. The Dynamic Data Warehouse component holds the most recent information and offers fast integration mechanisms, while the Static Data Warehouse component stores historical data. The Fusion component has access to both dynamic and static data warehouse components. In the last approach, the authors proposed a new model called Divide-Join Data Integration. This model is built on dividing the volume of data changes and the duplication of the fact table. In their study, using the model have shown real improvement in data integration rate compared with the normal configuration. The table gives a summary of the literature review, which is based on some criteria. The majority of the presented studies of real-time data warehouse did not specify the ETL real-time architecture. All of the presented approaches are concentrated on its architecture and non-detailed in the design and implementation of these architectures. The researchers mentioned the platform Talend Real-Time Big Data. It is a platform that simplifies the integration in real time for big data and advanced analytics and cases of real-time use that guides innovation in a company. They added that there is no existing work that models the various stages of ETL real-time and real-time data warehouse with a said platform. Because of this, the researchers suggested the use of real-time UML standard to model real-time data warehouse before building with the suggested platform. As the conclusion, the paper focused on the literature review of existing real-time data warehouse architectures. Then, it details the changes in the ETL process to deal with real-time data warehouse systems and treats the integration data in the real-time data warehouse. The paper only discussed proposed architectures from existing literature and has not given a more in-depth analysis such as comparing the approaches based on implementation cost, feasibility study, and closeness to a real-time data warehouse. The paper was able to differentiate a traditional data warehouse from a real-time data warehouse. With the increasing demand for timely data to ensure better informed decisions, this paper can be referenced by researchers and system architects for projects involving real-time data warehouse.